Welcome to Chatting with Chuck. I'm your host, Chuck. Today I'm going to talk about PC-based motion control. I just came across interesting information on this. Thought I'd do a little discussion on it. I'm actually all by myself today, so I'm going to do all the talking. So let's just jump right into this. For many applications such as light manufacturing, laboratory machines, and instrumentation, a popular way to implement motion control requirements is to integrate plug-in motion control cards into a personal computer platform. These embedded motion control systems combine digital signal processors, DSP, and field programmable gate arrays, FPGAs, and have become a mainstream method for design of open architectural systems based on the x86 PC platform. These form factors, which have mainly been driven by the specific computer requirements they work on, enable a typical PC hardware to be extended with powerful motion control capabilities, making this solution even more attractive. PC computational performance has increased greatly while the cost has been dropping rapidly. With the proliferation of powerful and economic PC platforms, end users have been looking for ways to simplify and consolidate motion control platforms to realize improved performance at a lower cost. Today, most industrial automation tasks use PCs to some extent or another, and both engineers and plant floor personnel alike are extremely comfortable with this economic yet powerful solution. But even a modern PC and multitasking operating systems like Microsoft Windows does not offer the required feature set to properly achieve motion control. This means PC platforms must be supplemented to effectively provide motion control. A motion control card can be installed into an industrial PC to achieve the best of both worlds: high-performance motion control combined with a user-friendly PC-based supervisory system. These motion control cards incorporate dedicated microcontrollers with a localized real-time operating system to ensure responsive operation. In addition, these cards include native support of industry-standard Ethernet protocols optimized for motion control. Furthermore, standardizing on a motion control card allows engineers to reuse the critical component for many different applications, while the supervisory PC can be configured with a variety of software packages to meet user interface and other needs. Hybrid architectures combining a PC with one or more integrated motion control cards offer a number of technical and commercial advantages for system designers as compared to traditional solutions implemented with separate motion controllers. Let's talk about some real-time basics. In the most basic sense, motion control applications are all about speed. For purpose of this discussion, we are considering not so much the speed of the resulting motion devices, but instead the required processing speed of the motion controller system. A controller system with enough speed can evaluate the position, velocity, and acceleration of motion devices, execute supervisory control logic, and command the available output signals, all fast enough so the system motion always remains within required parameters. If any of these actions happen too slowly, the result will be a system veering out of control. The PC system is performing numerous fundamental administrative tasks, such as checking the keyboard and the mouse, orchestrating some demanding activities such as updating the user displays, executing many user programs, and constantly coordinating so none of these tasks conflict. Along the way, calculations will always be correct, but it is less important exactly when they occur. A CPU is context switching very quickly among these tasks, and while it is really only doing one thing at a time, it does take each task so fast that the end result appears to humans like all necessary tasks are occurring at the same time. All of this switching coordination actually introduces an additional component, overhead load, which the issue of added delays, or makes it happen quicker. Yet the result reality from a human perspective and timescale makes it unimportant if any of these tasks happens a millisecond earlier or later than planned. On the other hand, motion control applications can definitely be impacted by such minute timing variations. The efficiency and stability of data processing and motion control processes play a critical role in achieving the desired system characteristics of high speed and precision. In these cases, not only must the computations be correct, but they must be supplied with fresh data and produce results in a timely manner. If any timing constraints are not met, the system failure may occur. Time-sensitive systems, such as described here, are said to be deterministic, which implies not only will functionality be achieved quickly, but it will be performed predictably for a given task. Of course, the response must be sufficiently fast to support the desired motion control performance. Operating systems able to provide deterministic operation are often referred as real-time. These real-time operating systems, RTOS, are necessary to achieve effective motion control. RTOS systems still perform fundamental tasks: management, scheduling, resource allocation, and interrupt handling, but in a way guaranteeing critical processes will occur in a scheduled manner. Motion control cards fit these requirements exactly. In particular terms, motion-based motor control functions must execute on the order of microseconds, while supervisory control works well within a millisecond execution. An ideal motion control implementation combines multitasking convenience with deterministic performance, even though the two methods would seem to be at odds with each other. That is why an excellent method of reaching this goal is to use a hybrid system consisting of a traditional COTS PC or COTS PC with a specialized RTOS motion control subsystem. This is possible by using other industry standard technologies, such as a PCI interface, to provide a high-performance motion control solution. So how do we do this high-achieving performance? Well, relying on standard hardware and software technologies is the best way to create a hybrid system for this type with the necessary reliability and economy. Fortunately, each of the requirements of constraints can be met by using off-the-shelf components. I'm going to explain out some considerations when building a PC into a high-performance motion control solution. 1. Reserve multitasking for the PC platform. 2. Offload critical motion computing tasks to controller cards. Package controller cards as standard high-speed PCI interfaces. Use controller cards employing DSP and FPGA technology to provide the required performance. Outfit the controller cards with an RTOS. Ensure deterministic operation. Include EtherCAT high-speed communication. Multitasking operations such as supervisory control and operator interface functions are reserved for the main PC. This keeps these demanding yet less time-critical tasks on a platform where they will run well and provide the best user experience. Motion control tasks, on the other hand, are offloaded to dedicated controller cards. The PC generally does not need any specific characteristics, and any contemporary PC could be up to the task. However, the challenging environments of duty cycles, it is advisable to use an industrial PC or IPC. Packaging controller cards into the PC mandates a high-speed interface between the two, and the standard PCI interface offers plenty of performance and also supplies the necessary power to the cards. A typical controller card would incorporate DSP or FPGA technologies, which are optimized for high-speed computations and therefore ideally, suited to provide the level of performance demanded by motion control applications. In particular, FPGAs provide state-of-the-art performance and flexibility to system architects to customize their projects with a flexible, programmable electronic circuit structure, making them ideally suited for motion applications. For similar reasons, a reduced instruction set computing RISC processor is often used in these applications. Controller cards run an embedded RTOS to provide deterministic performance for the motion application and can interface with the supervisory multitasking system without burdening or impacting either system. The final step is to ensure the motion controller can communicate effectively with the actual servo drivers. While general Ethernet and various industrial protocols have risen to prominence in many areas of automation, motion is a more demanding application requiring high-speed and deterministic communication. One communication technology tailored for motion applications is EtherCAT, building an established Ethernet technology. EtherCAT utilizes a flexible hardware topology and a unique, consistently transmitting data frame to achieve high speeds. Additionally, this structure provides synchronization through timestamping, critical for high-speed motion systems. High-performance motion control can readily be achieved in an open and flexible manner using PCs, dedicated controller cards, and numerous underlying hardware and software technologies. This combination provides excellent functionality and helps users achieve their goals. So let's talk about the benefits of a combined multitasking and real-time motion control solution. Hybrid motion control systems which combine PCs with motion control cards represent an optimal solution. End users will be able to realize a number of benefits when selecting this configuration. Let me give you some of those benefits. PCs are a popular platform, so users are very familiar with this technology. The Windows OS offers an easy-to-use multitasking environment. PCs can incorporate HMIs, eliminating the need for a separate component. PCs are open and can thus host many different types of software. PCs provide connectivity to upper-level computing systems. Combining the hardware and software platform instead of using multiple platforms saves space and cuts cost. Established embedded RTOS are reliable, predictable, scalable, and compact. Implementing control and system on chip (SoC) hardware with an RTOS simplifies software portability for a supervisory platform. And motion-specific control scripting simplifies and speeds development. Using commercial or industrial PCs for motion control solutions is the most significant reason designers and engineers will realize savings in the ease of use of benefits. PCs are a common, cost-effective, and well-understood product. They are a very accessible technology for engineers and technicians likely to be working with motion control systems. Beyond the common PC hardware platform, the Windows operating system is the most popular system worldwide for desktops and laptops. It provides a mature and highly developed user interface with a natural multitasking environment with exceptional ease of use. In great part, PC usability is derived from the detailed video displays offered by hardware and OS. During software development, these displays make it far more convenient and even more intuitive for users to configure the system. Once a hybrid PC motion solution is in operation, there is another significant advantage, which is the PC can act as a powerful human-machine interface, or HMI, for the application. This eliminates the need for an additional interface component and results in a tightly integrated system. Just as PCs can facilitate human interaction, they can also enable digital domain actions and communications. Windows PCs are open in the sense they can be used to run any number of programs complementary to the motion application. This can include historical local historization of process values, event logging, or related calculations or allograms. PCs can also provide connectivity to upper-level computing systems, such as supervisory controls, or even a manufacturing execution system for an enterprise resource planning system. This level of flexibility is simply not available or dedicated on custom platforms. Consolidating PC and motion control elements into a single hardware and software platform typically reduces cost and almost always minimizes the complexity compared to coordinating multiple different platforms. While the motion control card represents a more specialized piece of the puzzle, it still uses standardized features, making life easier for end users. For instance, the established embedded RTOS are reliable, predictable, scalable, and compact. They are highly tested and known quality optimized for this type of use. On the hardware side, motion control cards incorporate system-on-chip hardware, which integrates microcontrollers, coprocessors, signal handling, and other components into a compact package. This is the reason a powerful motion control card can be incorporated into a PC card format. It also means that resulting card is modular for most any type of PC, which simplifies portability to any number of supervisory platforms. Motion control cards also include certain mission-specific capabilities, for example, motion-specific controller scripting. This type of built-in support simplifies the work required by end users and speeds development. So in conclusion, many industrial systems take advantage of the performance offered by servo motors for motion control. When engineered properly, these types of motion control systems offer far better speed, precision, than traditional automation using reverse motors and limit switches, for instance. Since motion control is a demanding high-speed application, implementation used to require very specialized components which have to be integrated into the greater system. In recent years, as PCs and Ethernet technologies have risen in performance and prominence in almost all areas of industrial automation, engineers and designers have been looking for more costly integrate motion control with common PC platforms. While PCs are certainly fast and user-friendly, their multitasking nature and operating systems limit them to imprecise millisecond speeds, which is not sufficient for motion control when it's deterministic microsecond speed requirements. Designers and engineers needed a way to combine both sets of requirements into one integrated platform. PC-compatible motion control cards are the answer to bridging the two worlds. Designed with mission-specific processors and RTOS, these cards have plenty of horsepower in handling motion control while interfacing with the supervisor PC at the PCI speeds. The card's EtherCAT networking interfaces enable optimized direct communication along motion devices using an industry standard protocol. This hybrid solution not only provides optimal motion control but lets the user consolidate many functions and supervisory software capabilities into an open PC-based platform. Today's end users now have an excellent choice for implementing cost-effective and an easy-to-use motion control. Well, that's it. I hope I didn't chat too long, but I found a lot of interesting information on this topic, and it's popular right now, so I thought I'd just go through a lot of it. Hope that it was a little helpful to you. We'll see, if in time will tell. This has been Chuck with Chatting with Chuck. Stay tuned for further episodes.